For me, understanding the first principles is really the start of using any tool, and I like to go deep before I can actually use something to its fullest potential. And when I heard, the advice of just start writing in your journal, I've spoken about this before, it really didn't sit with me. Like, I didn't know what I was doing. I really struggled to get into Logseq, and it was only when I really understood how the database model of Logseq worked that I started to get more value out of it. Even when I was recording this video, I discovered some things which were really helpful in the way that I approach my database. So for those of you who don't know me, my name is Dario and I run this channel, and I'm very interested in databases. I'm not a computer engineer by training, so it's learning on the fly, and I'm just trying to share some of the things that I learn on this channel. So hopefully that's a benefit to you, and let's get into it. So if you get one thing out of this video, go check out Maggie Appleton's illustrations on databases. Super helpful. And if you want, you can click off now. But what we're going to go through today is looking at how your second brain is a database. Then we're going to look at how graph databases work, with starting with how relational databases work, because that's like a familiar mental model. I'm going to try and make that land with an example, looking from Excel to Airtable, then Notion and Logseq, how to still get tables out of your database, and then why I think a graph database is better for personal knowledge management. All of those things have their traditional timestamps, so let's get into it. So I've already spoken a little bit about why this is important to me. Like, understanding the database model really helped me get to grips with my own second brain and start maximizing the potential of Logseq for myself. I just want to look at how your second brain ends up being a database. To answer that question, we need to look at what your primary brain is doing, your meat brain. And for me, what that is it's storing information and then it's retrieving information. And that is by electronic signals and neurons firing. And ultimately, there's a pattern of encoding and retrieval. That's what I've put there below. So for me, a database system is all about effective storage and efficient retrieval of your notes. This is really the layman's example of like databases in everyday life. But the definition is an organized collection of data stored and accessed electronically from a computer system. So that's the Wikipedia definition. And I'm just looking at a couple of things which are not technically databases, but are helpful to think of from this perspective. So your shared file system at work, there's a hierarchy that you go into and you go and find your different folders for different projects, etc. And then you go deep into those projects. So there's a system of storage that you go and find information in. A task management spreadsheet. Again, there's information that's stored there, and it's all about retrieving so that you know how to manage your tasks as your team, or however you may go. The typical one that you'll see on any sort of database tutorial is an e-commerce store's order history. And there's a great tutorial which I'll link to, which is done by Lucidchart. And the idea is that you have a database of customers, then you have your database of products. Now, if I, as a customer, go into a store or an online store and I have an order and I want to buy a product, I then create an order where I put things in the basket and then I check that out, and that is how the store knows what I've bought. So that is now another database. So the order connects the customers to the products. So that's just another way that this information is stored. I'm not going to go into an example of that because there's that great tutorial which I'll point to, so let's not go there. What does this look like in a Logseq? So, or in any second brain system or personal knowledge management system. So the storage is all about how you are inputting information. So indenting, are you putting it in your journal? Are you putting it in pages? And then retrieval is all about queries and filtering and searching. So I've spoken a lot about queries, but I haven't really spoken about this database approach. And that leads us to the kicker of what I want to say. So querying our minds is an expensive function. It's difficult to go and retrieve information if it's not properly stored. So setting things up effectively saves you in the long run. It can be difficult, but it's really worthwhile. Okay, so how do graph databases work? Again, I'm just going to go into my layman's understanding of two key database features. So that's data storage. And what I mean there is it's just a container that you're putting your data in. That's the way that I think about it. Data bin, data bucket, whatever you want to call it. It's just a place where I'm putting the data in. And then uniqueness. So if I have an online store, let's use that example again, I am going to be identified by probably my email address, because email addresses are unique. There are no two email addresses that are alike. Or stores will use a customer ID often. I won't be stored by my name only because there may be other Dario De Silvas running around. I've actually had this problem with a couple of doctors that I went to, because where I lived in Joburg, there was another Dario De Silva who was on the records of a couple of the providers that I went to, which was really annoying. They weren't using ID numbers or email addresses. They were just going by name when they were contacting people, which wasn't very good practice. It's helpful to start looking at a relational database, as that's a very familiar sort of database that is used. And that's essentially a filing cabinet. Everything is placed in a taxonomy. You can use tags, but each file is generally stored and only available in one place. So I've put it on a shelf, and then I go and I find that one, when I need to find that one book or whatever piece of information that is on the shelf, I need to go to the correct shelf and find it. So this is the point there below. When you need to find the tile, you need to remember with what you tagged it, or you need to have good search behaviors. So the way that relational databases do this is they store everything in tables. So your foundational data bin is a table, and this will be covered in the examples later. What is different about a graph database? This is the cool thing. With graph databases, it is unstructured, or you can work with unstructured data. Everywhere is your table. So if I look at Logseq, the journal is my table, any page is my table, and all that I have to do is just tag the block with the correct thing. I'll get into that now. So the other components of it is that I can give one block multiple tags. So what that means is that that same single unit can appear in many different places because it's linked to more than one thing, not just a single table. So this unstructured data, what makes it all possible? And I'm sure many of you have heard of the block, the core building unit of Logseq, and that is what allows this graph database to have this powerful functionality of networking things and not just being put in one place. So every block or page has a unique address. That is, one of these principles of a database that we spoke about. So whilst you are entering into Logseq, it is storing it as a text file in the back end, but then the software is giving each block, each sort of paragraph or bullet point that you're entering a unique address that you can reference. So you can link blocks to pages using the square brackets and hashtags, and that is where you start getting that structure and enabling you to link one block to many things. You can also refer back to blocks. So say now I want to refer to the block above here, I can just say, so I'm linking to this block over here just by using the regular brackets. I've spoken about this somewhere else, but there's an important difference between pages and blocks. Pages are just a different type of block in a sense. They appear as nodes in your graph. So not all these blocks are appearing as nodes. A page is sort of like a higher level block that enables you to relate things to it. We're now going to go a little bit deeper than Logseq and look at graph databases. And it's all about nodes and relationships between those nodes. So with a graph database, all the information is inputted at the node and the relationships are first-class citizens. This is something which I saw in Neo4j's description and I really liked it. So this doesn't necessarily apply to Logseq, but I think it's an important backstory for understanding graph databases. So relationships can have a type and a direction. And the cool thing about relationships is that they can also have properties themselves. So let's get into a sketch. Let's start with a page in the Logseq terminology, which will be a node of Bob Bobberty. Now I'm going to give Bob a couple of properties. Let me do that in green. So Bob, in this database, he's a type. He's a person. His date of birth is 28/06/1980, and gender will be male. So these here are called key value pairs. Let me just underline them. These here are called key value pairs, and every node that I might want to add, person information will have these same things put in into that node. Now, Bob is the CEO of a company called ExampleCo. So ExampleCo, let's go there. And that is a type company. It doesn't need a gender or a date of birth, so I can just say date of founding or founded 28th of April in 2021, hypothetically. And I could put a whole bunch of different information there into that node, also using these key value pairs. So you can see here that I don't have to have a consistent naming or consistent application of key value pairs across these examples. So I've forgotten to draw a node here. So I now have Bob Boberty and ExampleCo. Those are objects in my database. Bob Boberty is the CEO of ExampleCo. But the relationship is really the ExampleCo has the CEO that is Bob Boberty. And this comes from a Neo4j example. So I'm just using that. So ExampleCo, this is the relationship, has CEO Bob Boberty. This relationship can also have properties. So the start date was in 25/05/2021. And the cool thing is, if someone else came along, say now John Jeffries, and we wanted to put him as CEO, we could then say ExampleCo has CEO, and the start date would be something different. So it's a 26th of September 2021, and this guy has another property, end date 25/09/2021. So the graph database allows you to add really rich information for both the nodes and the relationship. So this is the part of the video that will hopefully land some of these concepts. So I'm going to move from Excel, then into Airtable, then to Notion, then to Logseq. And this is progressing in the way that I think about databases. So our point of departure is Excel or Sheets. Either way, this isn't really a database, but it's a way that we can put in data in some sort of structured way or pseudo-structured way that we can retrieve it later. So most professionals have come across Excel or are familiar in working with this grid layout. And I'm going to look at an example of a project management framework using data validation. For the other examples, I'm going to use the same framework or the same materials for the example. But for this example, I actually went and dug up an old project management database that I'd worked on just because it was a very painful one to work with. And I am so glad that I don't need to use Excel anymore for this. So looking at this project tracker example, there's a whole bunch of activities which are here, and then like project areas. Although I've consolidated it down to only one project area with all the tasks that are there. And you can see there, it's a very nice looking spreadsheet. It's got start date, due date, progress, and then status. And I mean, you can see it's even got drop downs and all this great stuff. But the reality of this is that this drop down here is looking up information on this validation list here. So I've got these are essentially databases. So I've got progress statuses, I've got deadline revisions, things which I can just choose from this drop down here. No, sorry, it's a bit small text, but you know, so there is information there. And if you're familiar with using Excel, you'll also know like the using X lookups or index matches or V lookups is like the first iteration of that to find information on other tables. So that is the idea of all these different tables that you're trying to find information on. But it's super laborious to go and like do those things manually. Whereas if you use a proper relational database, you can find those things at your fingertips. And this leads us into Airtable. Airtable is a proper, beautiful relational database. What do I have here? I've got two tables, which are projects and tasks. And I've got all my different projects built into into the projects table, and I'm using the project description as a unique ID. If you're using like a proper database system, oftentimes you'll find that there's like a number there, and the headings of the different fields don't have spaces or whatever. But with Airtable, you can get around those things. So I'm not using proper database nomenclature. But anyways, I've got these two bits of information in tables. So I've got my projects and I've got my task. And the key thing here is that I'm relating these different tasks to the projects that they are belonging to. So if I go to my project here, start a YouTube channel, you can see that those are all the tasks that are related to that project. So that's this beautiful like relational database. Two tables relating the information. And the thing that you saw there in Airtable is that there's a very defined schema for data storage. When I input any information, it automatically creates the fields for all those different projects. So if I go here and I create a new project example, by default, that new project has all of these different fields, although they may be empty. That's a key point, that it's following a defined schema. Now, if I go to Notion, I think about this as a relational database with a little bit of graph database. So why do I think that? So it's because it allows me to create both pages and tables, and also show tables on the same page. So let me go to Notion quickly. If I go to Notion, I've got this demo projects, and you can see it's the exact same things that I had in Airtable. All the same projects, and they're also related to the tasks, which are these demo tasks. A little bit slower, which is one of the things that people always complain about Notion. So I've now got all my tasks, again, related to demo projects. So that same relational database feature where I'm allowed, or I can put information into the tables and then relate them. But the cool thing that I can do here is I can say, open this get alone page, and although it's got those features of the table up there, I can add additional information which is not related to that table. So I can just say, cool additional information, and you can see it doesn't actually enter the table at all. It's a separate instance. And I can just create a random page here, random page that doesn't have, let's just say empty with icon, cool. This is not linked. Okay, so that is a very cool thing. Another cool thing that I can do in Notion is I can bring in more tables into one page. So, that would be like your dashboard approach. So if I go here, I can say related, create linked database. So I can bring in my demo projects, and then I can do another related database or create a linked record, and then I can bring in my demo tasks. So now the cool thing is I'm able to see more tables on one page, which Airtable doesn't allow me to do. I'm just going to bring this onto my bottom screen just to highlight a couple of things. Going back to Airtable, this is my database, and these are my tables here. Now I could go a step out and go into all my databases, and I've got a bunch of different databases which will all have their own tables. If I go to Notion, it's a little bit different. I have this demo folder, for instance, where I have stored these two databases, but they could be anywhere. Like I could move these databases out of the hierarchy. So just to highlight where my databases are, so I have projects and tasks. So now the tables are in the side there. So if I go there, I can find that database table, and then I can find that database table. And you can see it's not in a specific database, but it's still a table that I'm able to relate anywhere in my Notion database. And yeah, as I've done in this dashboard, I've looked up those different tables. So that's how I access the two different things and where the differences are a little bit in Airtable and Notion. The nice thing about Notion is it allows you to enter a lot more written text, or it's more naturally accustomed to written text. Back to Logseq now. I think that last point is actually a little bit underrated. Being able to show the tables on the same page is super cool. I really missed that when I built a task management system at our company using Airtable. I don't regret it, but it might be worthwhile to actually move that over now for the purposes of being able to see both things at the same time. Okay, so getting into graph databases, and this is Logseq, Rome, Athens, Obsidian, all of them function on this graph database approach. The beauty about this graph database is that you can put information anywhere. It allows you to be very, very unstructured. So I can put information on a page, I can put information on my daily journal, and it doesn't matter where I put that information. It's very easily retrievable so long as I tag it. So each block can be labeled as what it's related to. There's no tables in Logseq. I mean, there might be a future iteration where there is tables and it looks a little bit like Notion, but for the moment there's not. And this means that blocks and pages are easily retrievable at the highest level by what they are tagged as or backlinked to. So let's look at the example now in Logseq. What do I mean by the information can be put anywhere? So you can see from my previous example video, I had all these tasks, related to different projects. Now, if I just search projects, and I'm using the shortcut Control K here, and I go projects, I can see I've got these 3 linked references which are projects. So I've made pages for these different projects, and there's run a marathon, and you can see I've specified their relationship, that this is a project and the status of the doing status is someday or maybe. And again, I've got I'm going to just ignore this example here and just go back, and then I've got build a house, and again it's also a project, and I've got the status someday maybe as well here. Now I don't have to enter information here necessarily. I could enter it in my journal. So bringing up my journal, I could say there is more information related to building a house. And then, oopsie, I just clicked onto that page, but anyways, and then I can say build a house. So I'm specifying the relationship there, or specifying the link there, not the relationship necessarily. But if I go to build a house, I now have that information or that block right at my fingertips. But if I was in another place, let's say find a contractor, I could enter another block over here and say this is just a test, and then I can again use this thing build a house, and then if I go to that project build a house, you can see there that I've got 2 things in the find a contractor page that are linked. So I've got this is just a test, and the fact that the find a contractor page itself is linked to building a house. So it really allows you to put information absolutely anywhere. Now, what I've done here is enter information at the nodes. So building a house is a node, it's a project node. Running a marathon is a project node as well. Starting a YouTube channel, all those things are project nodes. But now how do I do the tasks that are related to those nodes? So I've done things a little bit differently here to show different ways of doing this. If I go to my journal and I just scroll back, you can see for all the marathon ones, I entered them on the 25th of September, and I entered them under this block which has the properties. It is related to a project, run a marathon, and the status is to do. So now it's gone down a little lower. I could actually put this here, type task. So that's what I mean by entering the information at the nodes. Entering information at the nodes can be a bit time consuming and expensive from a procedure perspective, but it can also be quite rewarding. So I've entered information, all the different tasks that are related to running a marathon: buy running shoes, buy a running watch, find a training program, start training program. This is not a good way of doing it, and I'll show you why now. For the start a YouTube channel, I've entered the 4 different points: watch Ali Abdaal, buy a microphone, make video 1, read awesome clear and show your work. And they all, then I've entered these attributes below those blocks. So now what I want to do is I can go to start a YouTube channel, and you can see I've got these linked references, and it's showing me the tasks there. Watch Ali Abdaal for inspiration, buy a microphone, all the different tasks that I've related to that, or to this page. So there are many ways of doing this. If I go to the build a house example, build a house. Just going back to the run a marathon example, run a marathon. You can see it's not actually that nice, because the running shoes, or buy running shoes, is nested underneath that block. So it might not show, or it won't show when I do if I had to do this as a query instead of as a search using filters. So that's just one thing to be aware of. Now, if I go to build a house as the example, build a house. For all these tasks, what I've done is I've made pages for the tasks, which would be a super laborious way of doing things. But it's just to show that there are many, many approaches within this graph database, and thinking through the structure up front really helps later down the line. Looking at where to do things in journals or pages, I've got one of my videos, which is I think how to get started in Logseq. I'll link to that below. It's really helpful just to understand that a little bit better. There's a way to be able to still get tables out of your database. So the thing that you need to do is use attributes in your block information. And as I use key value pairs in my Bobbity and example co information, you need to use key value pairs in either your blocks or your pages. I'm going to go to an example which shows both of those things. So I've just opened a query page here, and I want to show what I do with my articles. I use that breadcrumbs template. I've spoken about it before. And if I now open my, or if I query where I've got the property type article, I get this nice table. I've also made the screen wider. And there I have all the information that I want from the articles that I've linked. I can actually turn off any of the things here. So let me just remove dates, publisher, title. Queries are sometimes a little bit slower if there's a lot of information, which is what I've got here. So, and if I turn off the link, for instance, we can just get down to like a nice description. And you see I've got a lot of tidying up to do to make sure that things are consistent, but we're getting there. So that is where I'm entering things directly in my journal. So if I open this, which one is a nice example? Here, composability with other tools, subconscious. This is very cool. So I'm just opening this in the right sidebar, and you can see I just entered it in September 1st, and there are my key value pairs, the attributes, all entered in one block: the description, author, type, link, and tags. So hopefully in the future, all of my articles are going to be in that consistent schema. And you can see that that's bringing the relational database in, where I have fields. Those attributes are the fields. So that really helps to sort out the information. Now I've also got books which are entered in pages. So you can see the query there is page property books. And I've dealt with that elsewhere. So I'm not going to get into it. There we go. So there you can see the pages of all the books that I've got in the database. And this book, finally finished reading it. We'll be making some videos on it soon, hopefully. And now I'm bringing up that page on the right. For some reason it's showing block reference up there, but that's really a page. And that's also got the same, whoopsie, I've just opened another one here. Things are going a bit slow, but you can see I've got the information there entered in that attribute style. Why do I think a graph database is better for PKM? For me, first thing is ease of input for storage. So there's no prerequisite for structure. You can just enter information anywhere, and that allows you to work in your stream of consciousness. You're not having to leave for different tools there. Like as I've said there, you don't have to leave your workflow, go from this program, then go to Todoist and Airtable, whatever you might be using. I still use other tools for task management, but I consolidate them from Logseq at the end of the day, and then I move them there. I can see a time when I'll be able to better structure my information in Logseq so that I don't have to do that, or the features start to enable that Kanban view across your full database, which I spoke about briefly. But yeah, it's just stream of consciousness. So really, really easy. The ease of retrieval, you don't have to know where you put it. That's really great. So if you use tags, it's super easy to go and find it, or if you backlink, whatever. And the search is really powerful. And then on top of that, you've also got very good queries. The really cool thing is knowledge traversal across your graph. So the fact that you can click on something and then shows you all the possible relationships, like it's got your linked and even your unlinked references there. So if you haven't put a word in square brackets or with a hashtag, it will still find that in your database and like show you possible connections. So that would be your implicit relationships instead of your explicit relationships. And then I spoke initially about the beauty of the graph view. Obsidian's got an amazing graph view. Logseq is getting there, I think, but it just allows you to traverse, go from one point to the other, across those nodes, following those relationships that you have specified. The final thing is speed and flexibility. So information is replicable in many places and can coexist in many different hierarchies. So instead of thinking, oh, where did I put that? In which folder did I go to? It could be tagged with the project, the folder, the person, and I can find that information either from all those three different angles. It doesn't have to be in one place only, and that is super, super powerful. If you had to do that in some sort of, traditional folder structure using Microsoft Word or something, and you change one thing, you wouldn't be able to find that path. You would get messages like this path does not exist or this file does not exist, whatever. So it's very flexible. You're not tied into one thing, but you can also impose a level of structure that means that you will get the benefits of the relational database side of things and will allow you to find information even easier. So just in closing, I think I am learning this as an outsider, and if I've said anything wrong or if you've seen some glitches in the way I explain things, please drop a message in the comments. Just some additional resources for this. Maggie Appleton's work on databases, as I mentioned above, super good. Like, go have a look at that. I'll link it in the videos. There's this really nice paper, really nice article called Graph Databases, Rome Research and Personal Knowledge Management. Shout out to the author there. The Rome Research white paper is also really good. Explains this like ability to find information from many different angles. And then if you're interested in databases, the Lucidchart ERD videos are also really good. That's entity relationship diagrams, which is all about mapping what a database looks like. So thanks once again for watching. I really, really appreciate the support. It's been nice to see the channel grow, and I'll hopefully see you soon for some GTD and some books and a whole bunch of things planned. They're just taking a little bit longer than usual.